Okay, I think we're about to start and we're ready to start. I'm Joanne Kwan, Senior CIRIA Senior Research Manager. And thank you very much for joining today's event to celebrate our CIRIA new report, CH2824, um, Climate Change, a good practice guidance for managing climate change. Just before I carry on with just a few housekeeping, you know, housekeeping rules that we need to go through. The event will be recorded and you'll be on listen only mode. If you have any problems, any questions during the event, please raise a hand and CIRIA staff will try to help you. There are plenty of, obviously, opportunity for you to ask questions, but please type your question on the QA box. And obviously, there might be similar questions that people have asked. So it'd be good if you can put a thumb up if you like other people's questions so that we can obviously focus on those are interesting ones. Please share resources in chat. There will be a this is the chat box. Yeah, there will be a feedback form as a CPD poll at the end. Obviously, CIRIA is very want to know how well we've done for the events and the project. That's why it's very important that you fill in the form. And please share your views on LinkedIn. So I know we have a lot of people here today. I think it's over 100 people has just logged on. I think most of you know who CIRIA is, but for those who don't know, CIRIA is a not-for-profit member-based organization. We have over 65 years experience in delivering collaborative research with the aim to actually improve the performance of the UK built environment and construction sector. So obviously, improving performance is a very wide phrase. We're trying to help people become more sustainable in general and more effective in the way they do things. Sorry. And you can see, as I said, we're a member-based organization, and this is just a snapshot of some of our members. As you can see, involve major consultants, contractors, clients, government bodies, regulators, academics, and other interesting parties. We have obviously some sort of what we call CIRIA ambition, which is sort of what all our work are based on. As you can see, there's no anything that's special from a lot of other organizations, but obviously things like sustainability, net zero, being more resilient to flooding, climate change, the topic that we're going to talk about, is through all our sort of the core of our work. And obviously being more efficient in delivering innovation is also our aims. I know for a lot of people, CIRIA is best known as publishing reports. We have published over 700 good practice guidance on all aspects of the construction process, shall I say, from geotechnical side to contact to land to water engineering, etc., etc. But on top of these guidance document that we published, we also do a lot of training courses, both open courses, in-house courses, and even e-training, because we felt that obviously we need to improve, in order to help people, we need to develop the right format of guidance. Some people might want training instead of just reading a book. We also do a lot of events, conferences, including today's event to promote our work in other interesting subject. Also, in the past 6-7 years, we also have established a number of what we call community practice, which are actually networks for different subject areas, such as soils, such as SUTs. So it's produced not just events, but becomes trying to develop into a hub for communication so that all the like-minded people can get together to talk about certain things and improve together. And also we have developed electronic tools like the CIRIA, which is a tool to help people understand the benefit of using SUTs. So that's perhaps something quite innovative. In terms of what I'm more familiar with and what I'm responsible for in CIRIA is the sustainable land reuse themes, which we have almost 30 years experience in working in the subject area. I don't know if you can see the slides very well. I think the font's a bit small, but in essence, we've published over 65 guidance documents on different aspects from something very sort of in some respect to us now quite basic nowadays on risk assessment to looking at remediation for what called challenging contaminants such as ground gases, asbestos in soil, PFAS, microplastic even, and UXO, and also challenging site or situations. I just want to highlight, this is why we have been working on the climate change issues for a while. So I've called, how we can all do better to deal with climate change risks. And also we've done a lot of work in soil as well, which is obviously you find sort of every single construction project, but how to manage it in a sustainable way is always a challenge. So this is a sort of summary of perhaps what we've done in the sustainable land reuse theme. So so let's see, so this is what CIRIA has done, but perhaps we should now look at what brings us together today. Obviously, you're interested this event when you look at the program. Obviously, we all know climate change is a severe issue. It's a challenge to a lot of construction projects. We have a lot of sort of extreme weather like Storm Babet in October 2023, which caused a lot of roads and bridge collapse damages in these places. And obviously, something I think most of you can relate quite closely to is the effect of changing climate on subsidence, which is obviously causing a lot of payout in the insurance side of things. Hopefully this webinar will discuss some of these issues and obviously highlight what we have found out and what guidance that we have developed in CIRIA Guide CH24. And obviously, I'm delighted and very honored to be able to share this event with three very well-known speakers. Dr. Jeff Card, who is the Managing Director of GB Card and Partners, Helen Macmillan, who is Technical Director of RSK Geoscience, who is one of the major authors of the report CH24, and also Dr. Sean Williams, who obviously Geotechnical Director also at RSK Geosciences. Obviously, he's done a lot of work and written a lot of part on geotechnical aspects of the report. So before I will hand over to Jeff, who do the first presentation, I just want to give you a bit of background about changing climate. I'm sure a lot of you already know a lot about the subject, but obviously awareness of changing climate has improved or increased quite a lot in the recent years. But perhaps, shall we just go back to basic, like a lot of things? Shall we have a look at some facts first? Climate is always changing. It's been changing for thousands of years. It's a normal cycle. That's what the United Nations said as well. But what is not normal and what is, getting our industry and ourselves very concerned is the speed at which the climate is changing. the speed is so fast that it's basically the environment, human beings, plants, and also the whole ecology is not able to cope. We can't evolve quick enough to adapt to the changing climate. So that is what's causing the problem. And we already know there's a lot of fairly serious consequence of changing climate on both, you can see, causing flooding, damage on properties and land, and a lot of negative impact to the environment. And obviously, probably the only person now who still don't believe there's climate change is Mr. Trump in the USA. But as you can see, things like extreme weather events are getting more popular, and wildfire and flooding and other damaging is happening. So I don't really think that we need to look at the issue more seriously and have to think about and more importantly, to think of ways to deal with the problem. In general, as I said, people are aware of the changing climate. This is a study done by the Department of Energy Security and Net Zero recently. And as you can see you don't have to look at, this graph for too much detail. But what I'm trying to say is, majority of people in the UK, on average 75% upwards, are quite concerned or very concerned about the changing climate and the impact on their everyday life. One very obvious change is obviously temperature. The Intergovernmental Panel on Climate Change from the United Nations already saying that it's very likely, meaning that they said more than 50%, that the world is going to go up by 1.5 degrees between 2024 to 2040, and even double that in the following year by 2010. But you can say, why bother, a degree or two increase in Celsius is great, longer summers, we all like it that way. But what is not so good is, while our air temperature goes up, it also means that we're not more likely to have more heavy rainfall, more intense rainfall. And this is causing a lot of problems. Because why it's related is because for every 1 Celsius of increase in temperature, the atmosphere can hold 7% more on moisture. If you have more moisture, that means it's going to initiate more storms, more heavy rainfall. And that's why we can see the annual rainfall going up. UK as a country is already very wet. I would like to, this is a UK monthly rainfall days record for the Met Office. But one thing that perhaps I want to remind you is there's only usually 31 days at most a month. Some of them, half of the year is 30 days, and February got 28 as well. So if you look at that, this is quite scary because basically every month we have 7%, it's always raining, 75% days raining. And this year, I don't know where you are, but London's been raining almost every day for the past 3 months. So it is quite serious. And this is a photograph I don't think you're all very familiar with. This guy is at King's Cross, he's actually in a recent flooding incident. By the way, he's not trying to brush away the water, that's not possible. But he's trying to open up the drainage and clean the drainage. I mean, that's a very, very important thing. It rains a lot, meaning flooding, and flooding causes impact. So he's trying to clean up or clear the drainage to make sure the water goes away quickly. And this, on the right-hand side, is actually a bucket or whatever I put outside my garden the past few weeks. And you can see that is about 2 inches of water or rainwater that I got in almost 24 hours. So that's actually very serious. I was thinking we drowned all my plants in the garden, then what happened to my soil? And it's worse. I thought, oh, if you have to, build soil, relate soil to construction industry, impact on saturated soil, and how it affects the structures. That's also very important. And of course, as I said, this is statistic we have already. 1 in 6 UK homes are at risk of flooding, and obviously it costs millions and millions of pounds. This is a sort of a diagram that I've stolen from the report, which Helen and Sean will explain a bit more. But it's actually a very good diagram to show you all the geotechnical and geoenvironmental risks that changing climate will create, what the impacts are. And but anyway, I thought this is great because at least it gives you an over appreciation at this moment in time, and we can explain a bit more later on today. Then you can say, are there any guidance available to help you? During the past 2 years, been working on this project. I have researched quite extensively, look at quite details of what's available. And this is a list, and from, the land contamination risk management, which is a Bible for looking at brownfield site or how to risk, to HPC guidance on ground gas. There seems to be quite a lot or more on specific on ground gas. And obviously CIRIA mentioned sort of impact on extreme weather on our own guidance document on hazardous ground gas as well. And there's also quite a few guide on controlled waters, both the Environment Agency guide, which is a little bit older, to SEPA guide, and obviously most recently, the SOBRA, Society of Brownfield Risk Assessment Guide, which was published in 2022, which has been recently updated, I think about a month ago. So these are all very useful guidance, but there's not really one guide that talk about generically the geo risk, geoenvironmental and geotechnical risk. I think people are a little bit confused as a result of that. So this is why 2 years ago, I thought, we should actually develop something more to help you deal with these risks. So this is the aim objective of C824, which is Good Practice Guide for Managing Climate Change and Extreme Weather in Land Development, Effective Management of Geo-based Risks. I know it seems a bit long, but we have been thinking a long time about what the title should be, but this, I think, highlights everything that we're going to talk about. It's not just climate change, but also extreme weather events and how we can effectively mention the geo-based risk. We want to, as you can see, the aim objective is not just, the emphasis is not just obviously effective work or effective management, but it also means that we have to do it in a balanced and sustainable way. Because obviously there are a lot of other risks in any development that we have to manage. So that's extremely important. So this emphasis of balance. And obviously, hopefully with this guidance, we're able to help people to avoid delays in program, because we all know delays mean costs, extra costs, and also support how they manage such event in the future, because a lot of time is maybe your project is going to affect climate change or changing climate in 20 or 30 years' time. So future liability is something which is very important. It's something that your funders or insurance people, lenders are particularly interested in. So hopefully with this report, we're able to provide some answer for these questions. So why is C824 so special, other than the technical side we covered? Obviously, like any CIRIA project, is well supported by a group of expert stream members, which obviously I want to say a big thank you to them. But one thing that obviously I want to highlight here on the list as well is you can see the range of people we have involved. We have involved uh, technical people, consultants, contractors, clients, major asset owners, insurance people. We want to make sure that it will covered these guys are able to help us to make sure that, as I said, to create a very balanced report. And obviously, funders are the people who make this project possible. This is again is all the funders that I want to say thank you to. But as again, you can see the interest is very interesting as well because we have major, clients, major network owners, major consultants who are putting real funding to it, to retailers as well. So it makes that one thing I'm quite happy to see is the awareness of this subject has obviously is quite high, and it's a good start, and perhaps we can do more in the future. So I think I've said enough, and I just want to introduce the first speaker, Dr. Jeffrey Card, who's the Managing Director and a very well-known geotechnical expert in our industry. And he will tell us a little bit more about what he really thinks about climate change in real projects. So over to you, Jeff.
Good morning, everyone. Hope you can hear me. Thank you, Joanne, for that introduction and explaining all the background to the CIRIA project. In the next few slides, I want to demonstrate how big the problem is and some of the processes that we have experienced and that we need to be tackling. And I'm sure you won't have failed to be following the news recently over the past few months and over the winter period. You won't have failed to notice the recent storm and torrential rain events, flooding in the south and the southwest of the country, which is impacting the UK. And this illustration here, the dramatic scenes that we see on the east coast of England, where coastal erosion has resulted in the loss of about 11 properties at Hensby in Norfolk. And it's reported there that up to 27 meters of coastal erosion has occurred just in the last 12 months due to storms, high tides, and strong winds eroding the cliff faces. So climate change and extreme weather events are a fundamental engineering issue. And we see that going forward, climate change is going to introduce variability into our design assumptions, our geotechnical design assumptions, and how ground behaves in the future because of these longer and more frequent climate events. And it's important to understand that rainfall, drought, sea level changes are affecting soil behavior, soil properties. In summary, in essence, weakening the structure of soils and their strength and causing erosion effects, landslides, instability, subsidence, etc., etc. And in our infrastructure, the UK infrastructure performance is going to be increasingly linked to climate variability. And most at risk is the UK's long heritage infrastructure built in the last 150, 200 years. And we're seeing that and we experience that as a company right now. In fact, I spent the last week touring the Southwest, looking at heritage infrastructure and the damage that that has caused. But to give you an overview of the scale of the issue that we may be facing is that the National Railway Network is supported by something like 190,000 earthwork structures, that's embankments, cuttings, built again, in the last 200 years. Um, Never, when they were built, um, allow for extreme climate change. It was never sort of a consideration in the engineer's design manual. Again, we've got something like in the UK, 3,500 kilometers of canals. Again, 100, 200 years old. 1,000 kilometers of flood embankments and river structures. Millions of buildings on shrinkable clay soils. Much of that is in the UK, in the southeast, in the south of the country. Um, so we have a large asset base exposed to climate change. And I think, just to give another statistic, I think the EA predict that probably up to something like 20,000 homes are at risk from coastal erosion, mainly on the east coast of England, by the 21st century, by 2105. It's a major problem. And yes, more recently there's funding. Government sort of woken up and decided to put some funding together for coastal defence and flood defence barriers. But really, is it enough? We probably need to question that going forward. So just quick summary of some observed climate trends. Yeah, we've all seen increased intense rainfall events. And I think from experience that that's certainly happening over the last 10 years. They're becoming more frequent and a longer duration. So both rainfall events and then long summer drought conditions as well. So we're getting extremes of flooding and intensity of changing moisture content of the ground, and then long summer periods, dry drought periods where the ground is drying out, and we're getting a lot more desiccation cracking, which exacerbates the issue that when we then get the long rainfall events, penetration of surface water is getting deeper into the ground, and as you'll see in some of my illustrations, is causing land instability, mudslides, etc. And we're getting, as I said earlier, accelerating coastal erosion in vulnerable regions. And the illustration on the left here is actually in the River Arun in my local neighbourhood. We've seen extraordinary amounts of flooding very frequently. It's becoming more intense. And the illustration on the left is the Dawlish Warren retaining wall collapse in 2014, which took out only the retaining wall, but the ground beneath the railway tracks. So the economic and infrastructure implications, we're saying, yes, subsidence is a major source of structural insurance claims. And as a consulting engineering practice, we're saying we're getting more involved in looking at insurance claims. Certainly earthwork failures, disrupting transport networks, railway embankment failures or cutting failures seem to be occurring more frequently. Flooding and scour threatening bridges and infrastructure. This illustration on the right here is something recently which we've seen in the last few months. This is a footbridge next to a railway, and scour erosion during the February floods has caused scour underneath the bridge abutments and actually taken out the backfill behind the retaining wall, which I'll discuss. And this project here on the left-hand side is a canal embankment in South Wales, where desiccation, cracking, and surface water infiltration into this embankment has softened it, weakened it, and it's now, well, it has been sliding away from the concrete lining to the canal and taking away the footpath. And just about talking about foundation movement, and Joanne showed what reports are being taken, so especially by NHBC. But what we've been seeing a lot more is shrink swell behavior on clay soils. It's well known that behavior and desiccation caused by cracking and then tree root problems. As you may guess, that this photograph on the left-hand side is showing subsidence cracking, and we'll be monitoring this. But this is and we're seeing a lot more of this. This is in housing properties which are only 5 to 7 years old. So will have been built to NHBC standards. But what we've been experiencing when we've been doing investigation is that the effect of tree roots and desiccation has gone far beyond the prescribed depths that you would, if you followed NHBC foundation depths for tree roots, chapter 4.2, in some extreme cases. And this is on London clay. We found tree roots and desiccation cracking at depth of up to 2.5 meters, possibly up to 3 meters. And we've had to take in this case, the ground slab has had to be taken out, heave protection installed, and the actual ground slab has been piled because of the depth of potential shrinkage swell of the material, the clay. So we're seeing I think there's more. This is becoming a more of an issue, and it seems to be affecting not only older properties, but even more recent properties as well. So that I think is an issue we need to be, as engineers, be aware of and thinking more. Slope instability, another big issue. We've seen recent more events. Problem here on the left-hand side is a landslide on a railway track that blocked the track temporarily. But this is runoff coming off the field above the fence line, flooding a drainage ditch. The water has overflowed the drainage ditch, eroded the side of the ditch away, and the material, surface material over the cutting has then slid and pulled down rock and weathered debris onto the track. And this, on this particular piece of line, has happened in about 6 other places, and it's ongoing. So, major issue. And this here on the right-hand side, this is a gabion wall that was installed in 2007 to stabilize this cutting, and that was fine. But since about 2020, the increase in rainfall runoff of the field upslope here, I think if you can see my cursor, as well as desiccation cracking in here, has softened this material, and the whole of the cutting plus the area of that tree line has started to move, and the current landslip uh, undermined the gabion wall is actually daylighting in the track. And this has had now to be, this is 2025, 2026. We've had to sheet pile at depth to stabilize that cutting. So we have to be aware, that this is as a result of climate change, and we must sort of be thinking about all our structures going forward, if how stable these situations are. Next one. Come on. I don't know, it seems to have got stuck for a minute. I'll apologize for that. There we go. Right. Slightly different. Shrink swell subsidence. And this is softening. This is a problem with rising groundwater table, softening the ground. And this is illustration on the right is a pump house, which is actually in hogging. So it's actually breaking away in two, with cracks starting at the top at eaves level, running through the weakest points, which is over the arch. So it's actually sort of breaking its back. And this is another danger, that with more intense rainfall and longer events, that we're seeing groundwater rising in a permanent state and affecting properties. And again, I don't, this is an old structure. It's built to get about 1900. So again, never thought that it was necessary to build in and design for climate change. Yeah, here we go. So other aspects are soil erosion. This is recent from the storms over this winter period. This is a culvert on the extreme left-hand side. During sort of the February torrential storms in the southwest, the water level here rose to almost the top of the wing wall where my cursor is, and found its way, through this cavity, causing this actually is an embankment, eroding the embankment here to a railway, but also eroded the backfill completely out of this abutment to the footbridge in front of the culvert and has eroded also the foundations. So the whole well, as you can see from the footbridge, has skewed to the right um, with so at the time that this was being flooded, the water level going underneath this bridge was up to about here. So the extreme uh, flooding and a drainage surface issue. And this on the right hand side, this is a mudslide caused by uh, soil erosion coming off a farmer's field above this fence line cutting slope here. Um, it's where the farmer, this happened in 2023, had ploughed the field to plant potatoes for the next season's crop. That immediately having done that, there was um, a complete sort of week's worth of torrential rain, which washed the soil off the slope onto the railway. So this mudslide just here, just to summarize, overflowed the cess drainage and then flowed downslope, which is to the right of the railway track, and pushed over a Victorian retaining wall. And in the neighbour's garden, all this mud flowed with almost all the farmer's potatoes. So, yeah, she had a plentiful of winter supply of potatoes. And that gave us an interesting issue trying to work out the soil properties of spuds. So just quickly looking at canal embankments and affect what's happening. We've seen a lot of breaches in canal embankments, and this is actually my local canal. This is the Wayan Arun Canal on the left-hand side, and this is the River Arun in flood on the right-hand side. And you can probably just see there's a breach and scour erosion has occurred there, just in the background. But you can basically make out here a landslide. The whole of the embankment and the footpath, sorry, has slipped and is cutting off actually the river channel. So it's exacerbated the problem. And this has occurred back in February. It's still not passable at all, which is a great shame because this is my normal walking route to the local pub and is causing me a 3 mile diversion. But there we go. One has to live. Perhaps it's a good idea to reduce my alcoholic consumption. So just quickly, a few more slides. We talked about in my introduction about coastal instability, and this seems very, very vulnerable on the east coast of England, from Suffolk, Norfolk, up to the East Riding of Yorkshire. Soft cliffs and soils, very vulnerable to sea level rise and high tides, whipped up by strong winds, has been causing massive erosion, damage, and loss of properties. And this is going to be a big issue. And as I say, I think the EA predict that from coastal erosion, some 20,000 houses are at risk over the next sort of 50 years from coastal erosion. And government is looking to enhance coastal defences to mitigate some of that risk. Other aspects that we've seen, river scour. This is a railway bridge in Dorset. You can just make out this apron around the pier structure. That scour is occurring to the concrete apron. Um, the interesting thing about this is that this isn't the original river channel. That's the river channel in the background. But in the last 5 to 10 years, because of flooding, an increase in flooding, the river has made a diversion of a new channel, where this pier would have been land-based, and so there would have been no scour occurring on this side. So this scour is very recent, um, and is going to need attention. And river erosion, just to illustrate a point. This is the River Wye in flood. And again, because of long durations of it being in flood and saturating the riverbank, that when we have sudden rapid drawdown, it's destabilizing slopes. And in this particular case, it's in the rear garden uh, of the property fronting onto onto the river. And this is gradually being then eroded away at the toe by the river, and is then causing progressive land slipping, as well as increased rainfall and groundwater flow coming through the soils behind the slope. So to conclude, I'm just going to say that design infrastructure needs to take account of climate projections. And the key things are improved drainage and erosion protection, possibly implementing monitoring and early warning systems, and at most, our historic heritage legacy infrastructure is at most vulnerable at the moment. So key message I think to take away is that climate change is altering ground behavior. Geotechnical hazards and risks are likely to increase, and we need to be proactive in making our infrastructure more resilient to climate change. And yeah, engineering must consider climate uncertainty. And hence why the CIRIA research project C824 is very timely and valuable at this moment in time. Right, thank you very much for listening, and I'll hand over now to Sean and Helen.
Okay, thanks so much, Jeff. Now let's hear from our next speaker, Helen McMillan, Technical Director at RSK Geoscience, and Dr. Sean Williams, Geotechnical Director, also for RSK Geoscience. And obviously, they were the two major authors of the report C829. So over to you guys.
Okay, thanks, Joanne and Jeff, for your presentations. I think they provide a good introduction into the issues and challenges we face as a result of climate change and why we need guidance to help ensure our geotechnical and geoenvironmental assessments remain sustainable and robust into the future. So I'm trying to click on the slides, but it's not going. So it seems to be frozen on that slide.
You have to click the slide.
I am clicking. Hang on a minute. Maybe if I change to this screen. Yeah, I'm clicking, but nothing's going forward. Yeah, I'm
Maybe
clicking.
try
I'm trying with the mouse the arrow buttons that are turn
yeah.
key. I can't get it to shift from that slide. Oh, here we go. Is that it now? Starting to work. So myself and Sean are now going to provide an overview of CIRIA report C824, which has been developed by RSK Geosciences. It comprises a good practice guide for managing future climate change and extreme weather in land development. And we think it can help you by supporting decision making to effectively manage geo-based risks in the face of a changing climate. I'd like to also thank our co-authors, Tom Henman, Rosanna Bloxham, Zyle Hoke, and Andrew Fellows, who've been instrumental in preparing this guidance. The guidance has been over a year in the making, and we're very proud of what we've managed to achieve. And I'm looking forward to providing you with a taster of what to expect from the guidance. So initially, just a bit of a background to the guide. The CIRIA guide provides practical advice for managing geo-based risks in land development from future climate change and extreme weather events in a balanced and sustainable manner for sites located in the UK. The guide aims to provide a link between projected climate change impacts and extreme weather events, their physical effects, and the implications for geo-based risks. The guide covers the full development life cycle, including pre-construction, construction, and the post-construction phases. It will therefore be a useful reference document for a range of users, including landowners, developers, consultants, regulators, financial institutions, asset managers, and legal professionals. We've structured the guide into two parts. The first provides a comprehensive review of the current state of knowledge, and the second part presents a good practice framework for managing and mitigating the projected impacts of climate change on geo-based risks. The guide includes diagrams, tools, and case studies to support understanding, and we'll include examples of these in this presentation. However, just to note, the guidance is currently undergoing final publication checks, so some of the figures that you see might look a little bit different in the published guidance, but it'll be mainly down to changes in colour scheme rather than anything fundamental that we're going to cover in today's presentation. There are limitations to our guidance. It focuses on resilience and adaptation to future climate change associated with geoenvironmental and geotechnical based risks in land development only. It doesn't consider climate mitigation, although we consider that developments will ultimately become more sustainable if climate risk is assessed and mitigated as part of the planning and design of a development. There's a lot of research and development being completed in relation to climate change, which Joanne alluded to in her slides. Therefore, we've had to draw a bit of a line in the sand. So the references cited in the report are current up as of July 2025. Before I move on, I would also like to thank the project steering group for their contribution to the guidance, as well as those that we undertook detailed consultations with, and other colleagues within the wider RSK group who also helped support the preparation of the guidance. You saw from Joanne's slide that the PSG includes a representation from environmental regulators from across the UK, local authorities, clients, asset owners, the insurance industry, as well as geoenvironmental and geotechnical experts from other consultancies. We therefore consider that the guidance that's been produced represents good practice for the industry going forward. So first of all, we're just going to go through the first part of the guide, which provides a comprehensive review of our current state of knowledge. Again, if we can move on. So first of all, what are the main regulatory drivers that require that climate-related risks are assessed in each phase of the development life cycle and ensure that adaptation and resilience are considered? So we've got these grouped into three main standards. Firstly, if you can click on, we've got the Climate Change Act 2008. This is the primary legislation and mandates the need for climate change risk assessments on a country level and the development of national adaptation plans. For development, specific requirements are implemented through national planning policies such as NPPF and NPF4, and local plans and policies. Secondly, for major public sector funded projects, there are specific requirements for the vulnerability of projects to climate risks to be considered, such as the HM Treasury's Green Book guidance, and infrastructure operators and public sector bodies are required to assess climate risks to their operations and functions and report on adaptation strategies to assess these risks through the adaptation reporting power process. Thirdly, there are evolving financial appraisal requirements that have developed through the Task Force on Climate-Related Financial Disclosures, TFCD, and these are now being implemented through international and UK reporting standards, such as IFRS S1 and S2. We have linked these drivers to the different stakeholders, and all of this is underpinned by current and developing technical standards and guidance. So we have completed a detailed review of existing knowledge to understand what relevant and existing emerging standards and technical guidance consider climate change and extreme weather related impacts, and how these influence the investigation, assessment and mitigation of geo-based risks. One of the key outputs of the guidance is the collation of currently available UK climate databases and tools that practitioners can consult to understand how the UK climate and associated physical hazards such as flooding and coastal erosion may change as a result of future climate change. And we've compiled these into an easily accessible standalone appendix for users to consult. We've then distilled this information to understand current good practice and research that already exists in relation to the potential impacts of climate change and extreme weather on geo-based risks, and how these influence the design, construction and built phases of a development. We've also highlighted where there are knowledge gaps. Oh, can you go back, please? I haven't finished on that slide. We recognise that good progress has been made on integrating climate risk considerations into geoenvironmental assessments. In particular, the SOBRA Controlled Waters and Climate Change Guidance and Clear Mine Guidance are really useful industry-led technical guidance documents. However, with respect to geotechnical assessments, while there's been academic research in relation to climate change, notably Achilles, the findings haven't yet been incorporated into technical guidance for use by geotechnical practitioners for adapting designs for geotechnical structures. It was also recognised in the NHBC NF93 report that further work was required to mitigate the effect of climate change on building foundations. Research related to the impacts on geotechnical design and construction is ongoing, and it's anticipated that updates to current standards and guidance will be required to combat the current and predicted future effects of climate change. One of the biggest uncertainties in relation to climate risk is that we're trying to predict the future based on standard climate projections, which have been developed by models and tools, which have been informed by real-world measurements and underpinned by assumptions, and these are continually being reviewed and refined. The models consider a variety of greenhouse gas emission scenarios. All of them project that the planet will warm by varying degrees to the end of the century, with RCP 8.5 being the most extreme scenario, which assumes the world does nothing to combat greenhouse gas emissions, with global temperatures rising by 4.3 degrees. However, this might be overly conservative, as the current thought is that RCP 6.0, which projects a 3 to 4 degree warming, is the most likely future climate scenario. Uncertainty in the climate models increase the further into the future they aim to project, and also the models don't consider potentially catastrophic climate tipping points, and they may not fully capture the influence of extreme weather. Other data gaps include the availability of data sets for the associated physical effects of climate change, such as flooding and coastal erosion. However, the UK government agencies have only made these available for the worst case greenhouse gas emission scenario of RCP 8.5, which I've already said might be a little bit overly pessimistic. There's also an absence of data on how future climate change and extreme weather may influence groundwater conditions, particularly within superficial aquifers. So due to these uncertainties and potential conservatism, there'll need to be a decision made as to when to consider climate change adaptation. For example, should it be done at the outset of a project as part of a development's design, when it's perhaps easier and cheaper to install? Or should it be retrofitted at a later date when there's more certainty about the site-specific risk associated with future climate change? It's not an easy decision to make, and it is going to depend on a variety of different factors, which might include the life cycle phase, the level of risk that you're working to, the long-term benefit, environmental impacts of adaptation, as well as sustainability considerations and the cost to deliver these. So we can go on to the next slide now, please. So future climate change effects for the UK are projected to include hotter, drier summers, warmer, wetter winters, rising sea levels, and more intense storms. Climate whiplash, where there are rapid shifts in extreme weather patterns, such as from extreme drought to intense rainfall and flooding, are also of particular concern, and they're likely to be exacerbated by climate change. The guide aims to provide a link between these projected climate change impacts, their physical effects, and the implications for geo-based risks. So this slide shows how we've represented the key implications of climate change in relation to geoenvironmental risk. And we've just expanded one of the quadrants that you can see there so you can see it in more detail, which highlights implications for hotter, drier summers. So hotter, drier summers, so we can just click through the animations on the rest of the slide and I'll just discuss these now. Hotter, drier summers can include a physical effect such as reduced recharge and lower groundwater tables, and this may result in a change to the risk for geoenvironmental receptors, as it could have implications for sources, pathways, and receptors. For example, reduced recharge could result in physical changes to the source and/or change to the indoor and outdoor exposure pathways, which could affect the future risk to on or off-site users. Future climate change and extreme weather events may therefore have implications for the conceptual site model and associated contaminant linkages that underpin our geoenvironmental risk assessments. And we must consider these implications as part of our risk assessments and remediation strategies to ensure the site remains suitable for use over the foreseeable future. So I'm now going to pass you over to Sean, who is going to take over and look at more of the implications for geotechnical risk. So if we can go to the next slide. Thank you.
Thanks, Helen. My name is Sean Williams. I'm the director responsible for geotechnics at RSK Geosciences, and I've had the pleasure of being involved on the geotechnical side of this CIRIA report. Before I start, I'd like to say how clearly Jeff has illustrated the geotechnical problems that are resulting from ongoing climate change. This is a major issue that needs to be considered across the construction industry. The only positive thing I can see is the significant work that geotechnical engineers will have in the future. This slide illustrates the key implications of climate change on geotechnical risk and mirrors the slide that has just been presented for geoenvironmental risk. As noted by Helen, projected climate change effects for the UK include hotter, drier summers, warmer, wetter winters, rising sea level, and more intense storms. These changes will result in significant physical effects, which are shown in blue on the diagram, on the ground conditions beneath the site, including alterations to soil properties, groundwater conditions, and flood levels, amongst other things. This will in turn result in associated changes to the geotechnical hazards, and they're shown in orange on the chart. Geotechnical hazards and risks experienced at a site, such as the magnitude of shrink swell subsidence, surface permeability, and coastal erosion, to mention a few. I think they quite clearly were illustrated by Jeff in his talk. These changes will clearly have significant implications for land development due to their impact on the behaviour of geotechnical structures such as foundations, retaining walls, basements, roads, road pavements, embankments and cuttings, each potentially requiring modifications to their traditional non-climate change design. We have considered these impacts for all climate change effects mentioned above, which this figure shows. However, as an example, we've expanded the hotter, drier summer quadrant to explain this in more detail. For example, hotter, drier summers will result in moisture deficit. For example, hotter, drier summers will result in increased soil moisture deficit and an associated increase in subsidence of foundations on clay soils. Also, the extent and depth of desiccation cracking, also shown on the diagram, in clay soils will intensify, resulting in increased surface permeability and a greater risk of slope failure during subsequent rainfall. We move on to the next slide, please. So moving on to part two. Part two of this report is where we have endeavoured to help move the design of development projects forwards to consider the impact of future climate change on geotechnical and geoenvironmental risks. It presents a framework for good practice for assessing and mitigating the projected impacts of climate change on both geoenvironmental and geotechnical risks. It highlights the main considerations for assessing these risks in each development phase and also considers the implications for we haven't quite well, that's fine, leave that as it is, and also considers the implications for property transactions and associated environmental due diligence. It also details how to identify and assess climate risk factors on a site-specific basis using available future climate projections. The findings highlight the need to understand the implications of climate change on below-ground conditions for each site and the importance of integrating this into land contamination risk assessments and geotechnical design processes from the outset. The design stage typically offers the greatest opportunity to mitigate future climate change related impacts. However, there may well need to be a balance between incorporating full climate change risk mitigation into geotechnical and remediation design versus partial mitigation with later adaptation through retrofitting, as Helen has already discussed. Clearly, developers will be keen to limit their upfront costs, particularly considering the uncertainties in future climate change projections and how they may affect geo-based risks. This and the next two slides relate to the consideration of potential climate change and extreme weather event impacts on geo-based risks over the development life cycle. The guidance considers how climate change impacts on geo-based risks should be taken into account at the pre-construction, construction and post-construction stages, the definitions of which are presented on the right-hand side of the slide. This is illustrated in 4 process flowcharts presented within the report, the first of which is a general case showing the whole development life cycle in one figure and is presented on the next slide. These process flowcharts illustrate climate change related considerations that are likely to be applicable in each phase of development and how they link to the associated regulatory requirements appropriate at that phase. For the pre-construction phase, planning and other standard regulation requirements for development are included, along with design requirements where climate change impacts, including extreme weather events, will need to be considered. For the construction phase, interaction with health and safety and environmental management related legislation are included, along with the impacts of extreme weather events on temporary works design, which are of particular significance at this stage. For the post-construction phase, relevant consideration including operational asset management, land and property transactions, due diligence are included, along with the design of any planned or necessary retrofitting works, which will need to consider all climate change impacts going forward. We could just move to the next slide. This slide presents the general process flowchart from the report as previously discussed. It provides an overview covering the whole development life cycle with a focus on points where climate change and extreme weather event related impacts should be considered in relation to geo-based risks. This shows that such risks must be accounted for not only at the planning and design stages, but also during construction and throughout the life of the asset. We move on to the next slide. This case study provides an example of how a task force on climate-related financial disclosure, TCFD, risk assessment identified shrink swell subsidence as a key portfolio risk as part of an asset management appraisal. So this is at the post-construction phase. A housing and care provider with over 100,000 assets commissioned a detailed physical climate change and opportunity assessment to inform TCFD reporting. Key geotechnical based risks to housing stock were identified to comprise shrink swell subsidence associated with future climate change. Adaptation options for existing stock, retrofitting, and risk mitigation measures for new developments were identified. Financial impact assessment identified a potential impact of several million pounds for subsidence-related risks. So at the asset management stage, there may well be a requirement to consider climate change-related impacts on geo-based risks. In fact, for existing developments, this is likely to be required in the future as climate change will not have been considered at the design stage. I'll pass you back to Helen.
Great, thank you, Sean. If we can go to the next slide, please. So Sean's just illustrated how future climate change and extreme weather events can be assessed over the development life cycle. And I'm now going to provide an overview of the approach we've developed for integrating climate change and extreme weather events into geo-based assessments. We've developed flowcharts to guide users through the process, which considers the fundamental requirements of LCRM and Eurocode 7 that need to be included within our investigations, assessments and designs. Within these, we've included a series of environmental and geotechnical watch points to help competent assessors consider how the site-specific risks underpinning the conceptual site model or ground model may foreseeably change in the future due to climate change. The watch points take into account the objectives and data requirements needed to inform the assessment, as well as uncertainties and limitations. There are also watch points for ensuring that any remediation or geotechnical design is resilient and robust to climate change and extreme weather events over its lifetime. And for selected watch points, we've included some real-life case studies offering an insight into how the watch points can be practically applied. Critically, we've adopted an initial climate risk screen approach within the preliminary desk-based assessment stage. This is based on a review of available climate databases, as well as any existing site knowledge, in order to understand how future climate change may affect the initial conceptual site model and ground model, which underpin the subsequent stages of assessment. This allows those involved in geo-based assessments to quickly determine whether there are any site-specific risk factors associated with future climate change and extreme weather events that need to be considered within subsequent stages of assessment, or if they can easily be discounted at an early stage. The guidance also includes schematic conceptual site models and ground models to illustrate how geoenvironmental and geotechnical risks may change as a result of climate change and extreme weather events. So over the next few slides, we are going to show you some of the excerpts from the guidance, just to illustrate how we've considered these items within our geo-based assessments. So if we can go on to the next slide, please. So this slide shows a flowchart that we've developed for integrating climate change considerations into geoenvironmental assessments. And as discussed, it's based on the requirements of LCRM. LCRM recommends that the effects of extreme weather and climate change are evaluated through the initial risk assessments, so that's stage 1, and also within the stage 2 remediation options appraisal and stage 3 remediation and verification. Central to this process is the development of a conceptual site model, which is refined as additional data are gathered and interpreted. Within the flowchart, we've developed 11 environmental watch points to help assessors consider climate change or extreme weather event-related effects appropriately within each stage of assessment. And you can see these by the red diagrams illustrated on the diagram. So you can see the first environmental watch point comes in right at the start within the Tier 1 preliminary risk assessment. And then these considerations go through all of the subsequent tiers of risk assessment and then into remediation considerations. The guidance discusses how each environmental watch point should be considered by risk assessors to help inform decision-making processes and inform next steps. So we just click on, we've highlighted one of the environmental watch points, which is environmental watch point 3. So you can just click on the slide to show that. And this considers how projected climate change effects identified as part of the initial climate risk screen may influence the development or refinement of the conceptual site model. And I'm now going to move on to a case study example to illustrate how this can be considered. So this slide provides an example case study, which we've included in the guidance, and it illustrates how environmental watch point 3 was considered as part of a liability assessment for a former gasworks located close to a river. An initial climate risk screen using desk-based sources and climate databases, which assumed a worst-case greenhouse gas emission scenario, was completed, which indicated there would be no change to the flood risk, but a potentially significant increase in annual rainfall and recharge was projected, which warranted further consideration. The available site investigation data was reviewed, which did not identify a change to the conceptual site model as a result of future climate change. However, following extreme heavy rainfall, it was observed that discoloured water was ponding in the area of a former gas holder base, and when it was tested, it was found to have elevated concentrations of cyanide. So as part of the defined CSM, an additional linkage was identified as a result of extreme weather, which comprises the development of overland flow pathways to off-site receptors. So that was something else that needed to be considered, which wasn't initially thought about just looking at standard site conditions. If we can go on to the next slide, please. This slide is basically showing one of our schematic conceptual site models. So we've done this developed schematic CSMs to consider the effects of future climate change and extreme weather events on geoenvironmental risk through changes to contaminant sources, as well as receptor and pathway considerations. So this slide is showing the influence of hotter, drier summers, including drought conditions on the conceptual site model. So just using controlled waters as an example, a consequence of reduced recharge is that your unsaturated zone thickness could increase and also might have implications for groundwater flow dynamics within the aquifer. So I'm now going to hand you back over to Sean, who will provide a more geotechnical perspective. Thanks.
Thanks very much, Helen. Can we move on to the next slide, please? So let's take a look at integrating climate change and extreme weather events into geotechnical assessments. Central to this process in EC7 is the development of a geotechnical design model, which is refined as additional data are gathered and interpreted. EC7 recommends that the effects of climate change are evaluated as part of the investigation, design and verification processes. This slide presents this process as a flowchart and provides a series of geotechnical watch points which have been developed to help assessors consider climate change and extreme weather event related effects appropriately at each stage. In total, 13 geotechnical watch points have been included, ranging from those to be considered at the desk study stage. For example, GWP2 does initial climate risk screening, identifying these specific risk factors, through to those at the design stage. For example, GWP7 have uncertainties in climate models linked to climate variability being accounted for in the geotechnical design, finishing with those at the verification stage, such as GWP13, have new observations during construction altered the assessment of climate change related geo-based risks with resulting implications for the design. Interestingly, I think that last case is often important anyway, and I think bringing in the climate change is extremely useful. An example of geotechnical watch point 8, if we could just bring the animation up. Thanks very much. Watch point 8, are the assumed design actions appropriate for projected future considerations, is presented on the next slide. We can bring the next slide up, please. So, GWP8 case study example, impact of climate change on future design actions. On the 24th June 2021, the Chaplin Tower South building in Miami collapsed, resulting in the death of 98 people. You may have seen this on television. Substantial damage to the reinforced concrete in its pool area was found in 2018, partly due to failed waterproofing. The necessary repairs were estimated to cost $9 million, but they were never completed. Christopher Beckett, senior lecturer at University of Edinburgh, explained that sea level rise has been identified as a possible cause of degradation of the Chaplin Tower South foundations. Rising sea levels due to climate change can lead to saline permeating the groundwater, saline intrusion, and corrosion of the steel in reinforced concrete foundations if not appropriately designed. So it's quite a good example showing that the action, being the corrosivity of the groundwater, in this case has changed. Obviously, the building that collapsed hadn't been designed considering climate change, but going forward, these are the sort of things that may need to be considered. If we can move to the next slide, please. This slide provides an example of changes to the geotechnical design model as a result of hotter, drier summers, including drought-related extreme weather events. The geotechnical design model should consider changes in ground properties, groundwater conditions, and flooding that may result from future climate change. For this example, hotter, drier summers and drought conditions would result in physical changes to the condition of the surface clay soils, with a reduction in soil moisture content and an associated increase in the depth of desiccation. This would result in an increase in depth of surface cracking and permeability on clay slopes and potentially slope instability in times of future rainfall. Again, Jeff's slides clearly showed examples of this. In addition to this, increased depth of desiccation could result in greater than expected subsidence of foundations on cohesive soils and greater levels of heave in the subsequent winter months when ground levels rebound. Clearly, this is a problem that we need to think about and how to modify our current design procedures. Other similar diagrams are included in the report for the full range of climate change effects. We can move on to the final slide, or second final slide. To conclude, we consider that CIRIA report 824 can help provide practical guidance for effectively considering the impacts of climate change and extreme weather events on geo-based risks across the whole development life cycle. A reference document collating relevant databases, tools, guidance, and standards within a single report. A framework for integrating impacts of future climate change and extreme weather events on geo-based assessments over the whole development life cycle. Environmental and geotechnical watch points for each stage of assessment and supporting case studies to enable effective climate risk screening. Ultimately, we hope it will help geotechnical and geoenvironmental professionals avoid delays and additional costs in land development projects being occurred, support the securing of funding from lenders and obtaining appropriate insurance protection, and finally, reduce future liability and cost. Just go to the next slide, please. Finally, we're going to leave you with some quotes that we have received to date for you to read. Thank you very much for your time.
Right, thank you very much, Helen and Sean. So we're now going into our QA sessions. So please could Helen and Sean remain online, and your webcam and the microphone's on. We're also delighted to have Dr. Tom Hanman, Director of RSK Geoscience and RSK Environmental Limited, to join this part of the event, who's also obviously, as you hear already, he's heavily involved in developing the guide H24. Sorry.
Thank you, Joanne.
Yeah, it's okay. Sorry, for some strange reason, I switched my video off. So hopefully he will be able to enlighten us with a few questions. We have obviously received a few quite interesting questions, which I will tell you in a minute. But if you haven't submitted your question, if you still do, you can still do now. And also remember to click thumb up so that we can identify the most popular question. So the first question I have at the moment, got off a little while ago, is actually directed to Jeff. Oh, Jeff, could you?
Yeah, I'm on.
Yeah, sorry. Okay.
My video's on.
Yeah, okay, that's fine. I couldn't see it. That's fine. That's fine. It's a question to you. So do you also have examples where climate change has positive benefit to geotechnical themes?
That's a very interesting question. I can't think of one except increased vegetation cover has reduced soil erosion, but it's very unique because it's the type of vegetation that was being used, and that's not in this country. That's in South America, where I've had some dealings with. But on the whole, I have not seen any positive examples. No.
I suppose with earthworks, there may well be a more defined period when earthworks can be carried out. So during the summer,
Yeah.
it may become more definitive not to try and carry them out in the winter. I suppose that may be considered a positive. I don't know.
Okay.
Yeah.
Okay, right. Another question here saying, do you think geotechnical and geoenvironmental climate change risk assessment should be mandated as part of the design development of life cycle, as it seems that it's currently not needed? And it said, oops, sorry. And perhaps the need would be influenced by lending insurance institutes, or AI too could play a role in the assessment.
Should I kick off on that one?
Yeah. Yeah, saw that. Yeah.
So essentially, what we've looked at as part of this guidance is the way this is evolving, and at a very high level, UK national level, and for each of the devolved nations, climate change risk assessments are being produced that shows this does need to be done, both in terms of design stage, but also as Jeff has eloquently talked about in terms of management of existing assets. We're starting to see that come through in planning policies. NPPF, the latest consultation, just beefed up the climate change requirements new developments. LCRM, on the geoenvironmental side, mandates a whole number of things about considering climate change and extreme weather at every stage. But the gap has been until now is, well, how do you actually do that in practice? And it's been really useful to have the regulators on the project steering group to provide their perspective on this, because at the moment, it's very hard to say whether an assessment is compliant with LCRM or not, because they say that detail of how you actually apply climate change risk into, how you develop your conceptual design model, how you undertake your risk assessments. The detail's not been there, and that's really what the framework we developed for this guidance is intended to do, to fill that gap. Sean or Jeff, I don't know if you want to comment on the geotechnical perspective, equivalent geotechnical perspective on that.
You or me, Jeff?
You go first, Sean.
Yeah, I mean, when we say mandate it, make it compulsory, I suppose. I mean, I think the reality is it's going to become compulsory anyway, in that I think insurers and legislation will make it such, to be honest. I think it would be extremely difficult not to be considering climate change now in your designs and your remedial works. I don't know if that makes sense to you, Tom, but that's me sort of at a sort of basic design level, just thinking about it. I just think it's very difficult to see how people couldn't take it into account now.
Yeah, and we've talked about some of the factors that are going to drive that behaviour on the regulatory side. In terms of the financial reporting standards and the need to assess climate risks for large organisations listed on the stock market and so on, and for those that are caught up under the ARP adaptive reporting power, which is another requirement of the Climate Change Act. But I think the other part of the question was also talking about sort of influence of lenders and insurance institutions, and I think that's a really important angle to this. Every time we see a heat wave now, there's then a subsequent impact in terms of insurance claims for building subsidence, and the Association of British Insurers have produced quite a lot of information on that, which we've looked at. Obviously, every time there's a major storm event, there's flooding related damage, so there's no doubt that pressure will come through that route as well from the insurance side, from warranty providers like NHBC, and how that affects the evolution of their future standards.
Yeah.
So it's like a sort of pincer movement where a lot of different factors are going to drive behaviour, I think, in terms of mandating these types of assessments. And of course, consultants and designers will also be mindful of their professional indemnity insurance and potential for future negligence claims.
I think that's a really important point, Tom, actually, because you're going to have to start thinking about, if you haven't informed somebody, what might happen. And I think that's a really, really good point.
Yeah, I totally agree. I was just going to make that point that I'm sure professional indemnity insurance will be looking at this, and all our consulting engineers will be having to take this in account. So I think pressure will definitely come on to us. Yeah.
Okay, interesting. The next question is, which RCP pathway and spatial units are being used across the sector as the foundation? Well, that's quite specific, looking at foundations for death studies, given the range of different probable future these represent.
I'm happy to take this one forward. So the RCP pathways are the pathways that the global climate models have looked at to look at how the climate may change in the future as a result of different greenhouse gas emission scenarios. There are a variety of greenhouse gas emission scenarios that are considered. It goes from RCP 2.6, which is a low risk. It basically means you have to go beyond net zero to achieve through to the worst case, which is RCP 8.5, which I've indicated. So definitely in terms of data sets available, those that have been modelled for that worst case climate of RCP 8.5, they are the most comprehensive. They look at, there's regional climate models that look at specific issues in the UK climate. And also, as I mentioned in the presentation, in terms of the physical effects of climate change, the UK government agencies have developed things like, flood risk maps, coastal erosion maps that consider future climate change, but they are based on that RCP 8.5 pathway. So there is a bit of a data gap. So I think in terms of desk-based studies, particularly when you're looking at the physical effects of climate change, which informs a lot of what we consider in our risk assessments, we're kind of stuck a little bit with RCP 8.5. But that's one of the reasons we've done this climate risk screening approach, because if you can screen out risks at an assumed worst case, the most pessimistic scenario, then you can be confident that, maybe future climate change or different aspects of climate change may not be relevant to your site. So you can knock them on the head at an early stage. And if they are projected to be a risk, well, then you can take things further. And we've provided some examples of this within the flow charts and watch points we've produced in terms of looking at site-specific data. So yeah, we are a little bit restricted in what we can do. There are a variety of emission scenarios, as you've rightly pointed out. But at the moment, until government agencies can extend the climate risk scenario to maybe a more optimistic RCP 6.0, which is kind of what current thinking is that the sort of climate is going to evolve into, then it's initially doing that risk and finding out what we can take forward from there. So hopefully that answers your question. And as I said as well in my presentation, we've done the legwork and got all those climate databases that you may need to use in your assessments, and we've put them all into an appendix, so you don't have to go running around looking for them. We've compiled them all into one easily accessible appendix, so at least you know where all the reference sources are.
Okay, thank you. Another questions, perhaps a little bit difficult because none of you are local authorities or from the public sector. He said, what role do local authority planning departments have in requiring developers to incorporate climate change related geo risk assessment, particularly for ground condition that may evolve over the lifetime of a development?
Well, I've touched on that one already in terms of what environmental health and contamination land officers are looking at when site investigation reports are submitted under planning. Clearly, they're reviewing those reports against requirements of LCRM, which, as I mentioned earlier, does mandate the need to look at climate change and extreme weather impacts, right through the site assessment and remediation process. But to say that the gap the feedback we've had from regulators is the gap until now has been, well, how do you actually do that in practice? How do you consider that on a site-specific basis and integrate that into your conceptual site model? So that's what we're now able to do. Obviously, we hope that regulators will take this on board. They've been closely involved in its development, and see it as good practice guidance, and encourage developers and their consultants to now apply that, and so that will hopefully address that particular issue.
I think from a geotechnical point of view, it's probably less. This is not considered as much anyway, because I think with the LCRM, you've already got something there that draws people from a geoenvironmental background. I think geotechnically, probably exactly what you said, people didn't know what to do, and maybe now that we've got this guidance, people can start, the councils can start to think how to adopt them.
Yeah, I've just got to add as well, there's the NPPF consultation, which is out, and that's becoming or includes climate change considerations within that, particularly for planning applications going forward. So it might be something that sort of we see a policy change, which requires it to be looked at further as well.
And I agree with the comment that Paul Nathaniel's just put on there, that if a proposal ignores climate change, then it does beg the question of whether it can be considered sustainable development. And if it isn't sustainable development, then it's not compliant with NPPF and the equivalent planning frameworks in each part of the UK.
Right, anybody else have anything to add? We got 3 minutes left for questions. Just one last question is, could climate change introduce emerging ground instability risks in existing development constructed by engineered field, where the original design assumptions may now be outdated?
I'm happy to answer that, and I think the answer is yes. I think we have got many developments that won't have considered climate change, and there is a danger for those developments that, you know, they may struggle when we see this climate change, and there's a fair chance that retrofitting may well be required. I think with land transactions, this is going to become quite a difficult position for people, because they'll need to consider whether the properties they're buying have got enough resilience in them or not. So I think they definitely can become unstable. There is no question about it. I'm not saying they all will, don't get me wrong. I'm not trying to be an absolute humbug, but there certainly will be certain developments that will have problems.
And as Jeff highlighted in his presentation, sorry, Jeff, there are properties and structures being designed and constructed now, which that there are going to be risks in the future because climate change isn't being considered in that design process sufficiently. So there's a risk of what's happening now. There's going to be locked in risks for the future. So hence the need for this guidance and for this to be implemented quickly. Sorry, Jeff.
No, that's fine. I totally agree. I just also add, I had an interesting question the other day, was that how does climate change affect things like archaeological structures, like old forts, hill forts, possibly even structures like Stonehenge? What effect does climate change have on those sort of heritage structures? And don't know the answer to that, but I mean, trying to do remedial works to ancient, historical landmarks, very, very difficult. But I think, as both you and Sean have said, that the bulk of our heritage infrastructure will require thinking about retrofitting and mitigation measures.
Right. Thank you. Anybody have anything to add? Right. So anyway, I think we was towards the end of the event. Sorry. And sorry. Just it's for me to say, obviously, a few closing remarks. I think obviously climate change is a real and severe problem, if I dare to say, to construction projects. Especially, I think, although we know roughly that summer's getting hotter, winter's getting wetter, but these are still predictions, and we're not exactly sure this will happen. And I think make design of construction project quite difficult, because I think we all like more assurance about what we do. So I think we're all learning, and hopefully CH24 is the first step for us to pay more attention, to find more solutions to the problem. So C824 is not available today. You can order in advance so that it will come, you would receive it once it's ready. And I have to say this, we're offering 20% discount to you guys who's attended this event until 3rd of April. So hopefully what we have told you today will make you interested and perhaps consider buying a copy of the report. And this is again a slide just about to tell you about what some of the forthcoming CIRIA event. Just want to highlight to you in particular this we're doing a virtual event on PFAS on the 16th of July. It's obviously a very hot topic itself, but obviously it is also related to, how we can do remediation better with changing climate, with dealing with this, whatever we called forever chemicals. Just for sort of closing remarks, I think we have discussed, Sean, in particular, Sean, Helen, and Tom in some respect, some of the knowledge gap or research areas that we still need to do on this subject area. And it's actually highlighted in chapter 10 of the report. And you can see that although it looks like that more needs to be done on the geoenvironmental risk side of things, and less so on geotechnical risk, but actually, I think as guidance development-wise, geotechnical risk is actually less mature. So, for example, we're trying to do more on Euro Code 7. So these are some of the things that perhaps you can have a look at it, or after you read the report, think about it. That's what I was going to do. And obviously, it's also highlighted a number of different unknown areas from construction phase and post-construction phase. But I hope that this report will lead to more research. And to be honest, to move forward, these are the areas that we need to focus on. And so I know this is a repeat slide to Helen and Sean's, but just to demonstrate that at least some of the people involved in this project feel that the report is good, I think, but more so that we need to do more on the subject. Because I feel quite passionate about it, because when I started working this project about 2 years ago, I dare to say not a lot of people is that interested in climate change on geotechnical and geoenvironmental risk. And a lot of people are very aware of, flooding, knocking down houses and things like that. And it has been an uphill fight. And I'm very pleased to say that, 2.5 years on or 3 years on, we got people saying these very positive things and also wanting more help in this area. CIRIA also do a lot of other projects, I said, under the Sustainable Land Reuse program. In some respect, all of them are related to climate change in some respect. For example, the soil work that we've done from the reports, community practice, and more recently on the decision-making guidance we're trying to develop, because I think that's important. Obviously, soils is a great carbon capture as well. So it is extremely relevant to what we've done on C824, and perhaps it's an aspect we should look more into it. And PFAS, I know it might sound really unusual or different, but as again, this forever chemical, we're still not quite sure how to remediate yet. But as again, with extreme weather conditions, we'll only make some of the new remediation technologies, which are not tested, worse. So how to deal with that, I think we need to be considered. And funny enough, when we did the guide in 2024, I don't think we mentioned too much about it. So perhaps that's the area that we can do more. And we're doing one on client's guide, hoping to mention liability. But as again, it is also related to this. training site. We've got one on looking at former landfill and quarries, as again, it's all very close to it. But last and not least, I just want to say that I think we all have good intention. We all know we should manage climate risks, reduce our carbon emissions, manage extreme weather event better. But I think we actually need more actions to it, because otherwise we will still be where we are. The problems will still exist. So I think one thing I've learned from the report is perhaps we need more action and how we can do it. That's the next step. And more collaboration as well. This is something that CIRIA is very proud of. Collaboration is making all our perhaps 700 report useful and authoritative. But as again, climate change, involves so many people from not just the engineers, but insurance, clients, consultants, everybody. So I think collaboration is vital to make it possible. And hopefully we will, unfortunately, things like extreme weather is going to be more frequent in the future, but hopefully our infrastructure will be more sustainable, we'll have more resilience so that we can do it and hopefully not live in a boat forever. So again, I think thank you for speakers and all of you for coming. So the one last questions, perhaps you can put your ideas on the feedback form, what else do we need to enable people to manage the risk better? What action do we need? And that's my email address if you want to contact me. And I think that's all I'm going to say. This is again, the details of the report, which will be out very soon. You can buy it now so that you will have the report accessible as soon as possible. So anyway, so that's all I'm going to say. I hope you enjoyed the event. If you have any questions to the speakers, to myself, to other CIRIA staff, please let us know. And have a good afternoon.